Okay, we're now going to go through part 2, which is obtaining the graphs of motion. And this is a reasonably simple exercise. So we're going to bring back our graph view by clicking this little blue arrow here. And we're going to untick these vectors, which we no longer need, and we'll keep that x position so we can see what point we are at. Now, to obtain the displacement time graph, the velocity time graph, and the acceleration time graph, we're going to click on this plot button, and we're going to choose 3, so we get 3 separate graphs. These are all the wrong graphs, but we can change them. And so displacement time looks like this: x position against time. Velocity time graph, that's our x velocity against time. And then our third one is the acceleration against time, which is our x acceleration versus time. And we can see that the displacement time graph is clearly a sine graph. Our velocity time graph is clearly a cosine graph. And our acceleration time graph is clearly a negative sine graph. So it's pretty much has the same shape as the first one, but it's upside down. Okay. And we can also see that at the starting position, the displacement is 0, the velocity is maximum, and the acceleration is 0. At its maximum position here, we can see that the displacement is maximum, the velocity now is 0, and the acceleration is a negative maximum. And back at equilibrium, we're back at 0 displacement. We now have a negative maximum velocity and a 0 acceleration. And at the last point here, we can see that the displacement is now negative maximum. The velocity is back to being 0. And the acceleration is now positive maximum. So to copy these graphs, we can just click Edit and copy image and plot view, although you might want to maximize them like this before you do. I don't know if that looks any nicer. I think it might be nicer like this. Okay, so that is our graphs of motion. And what you need to do is to determine the amplitude of the motion, which you can do from the max values on the displacement graph. And you can use your equations for the motion. These relate to the equations of sine, cosine, and negative sine, which are given on your formula sheet. You can use those equations and the angular frequency and period that you calculated in part 1 to write out the equations of motion for this particular pendulum. And then you can compare these max values here with the max values of acceleration and velocity. So the maximum velocity, according to this, is 0.308. And you can compare that with the max value that you get from your equation that you got.